In this case study, we're going to go through an example of scraping data from Wikipedia, parsing it, cleaning it, and then making a graph out of it. The basic idea is that this might act as your introduction to web scraping. If you weren't too convinced by the Pasquale example or the books example, then this might be an easier example for you to get started with. And Wikipedia is a pretty popular source of data, so it's a good example to use. What we're going to try and do is to make a graph that shows the ages of each of the Canadian Prime Ministers going back through history. And although this may seem like a lot of work to make what is a fairly simple graph, the nice thing is that we could pretty easily add to it and add many other countries to it now that once we have the basics. So the main readings related to this lab, the first one is to do with Harvest, which is the package that we're primarily going to use. And then I've given you two other examples, so one by me and one by somebody else, where we go through and scrape some data. And so if you're interested in learning more about this, then these might be readings that you might be interested in. The main concepts that we're covering in this lab are respectfully scraping data, because it's important to not take advantage of the data that is available, cleaning the data, and turning that data into a story, in this case via a graph. We've seen the tidyverse plenty of times before, but we're going to introduce the Harvest package, which is the main package for scraping data within R, and the baby names package, which is just a nice little package that brings census data of baby names. And so in our case, we're going to use it to simulate some data sets. The main functions that we're introducing today are geom segment, which is going to be a new ggplot type of graph. Then there's going to be 2 or 3 functions to do with scraping and parsing data. Selector gadget, which is going to make it a little bit easier for us to work out which data within the HTML page we want. And finally separate, which makes it a lot easier to clean data sets. So in this tutorial, we're interested in answering the question of how long do Canadian Prime Ministers tend to live and how has this changed over time? The way that we're going to answer that question is by constructing a graph. Now, typically, we need to identify the data source that we're interested in. In this case, we're going to go to Wikipedia because it's a reasonably popular sort of article, and so we expect that it should be reasonably accurate, and the data is nicely formatted. The key library that people use for scraping data in R is Harvest, and the thing about Harvest is that scraping websites is never easy. It's always frustrating. You always want to tear your hair out and you always regret starting, but it's often worthwhile because you end up with really nice data sets. That said, if you find yourself getting frustrated and annoyed, that is perfectly normal. It happens to me all the time, as those of you who actually attended the lab on Thursday evening would have seen. That said, it's always best to begin with an end in mind, and so even though we're not modeling data in this lab, we are just going to make a graph out of it. I do still find that it is useful to simulate data. This is for a few reasons. Firstly, when you are scraping data, it's really easy just to keep scraping, and so it's important to begin with an end in mind. And if you simulate a data set, then you sort of understand what you're aiming for. Secondly, it can identify some issues that you might otherwise ignore. So for instance, it makes it obvious that our age should be some value between 50 and 100. And if we get some values for age that are like 500 or that are like 10, then we might suspect that we have some issue with our dataset. Or it identifies that our birth dates should be somewhere between 1700 and 2000, and that our death date should be at least 50, 60 years ahead of that. Finally, it's useful to simulate data if you're working in groups, because what it means is that one person can focus on scraping and cleaning the data towards making it look like what you simulated, and the other person can get started on the graphs and analysis because they can just start writing code based on the simulated data, and then when the real data is ready, then you can just replace the simulated data with the real. So let's get started. We're going to use the baby names package to generate more realistic names for our prime ministers, and then the tidyverse, which is going to make a whole lot of things much easier. So our simulated dataset is going to be made up of a list of 10 prime ministers, and here I am just sampling from some of the first names in the baby names package and sampling 10 of those. I use replace as false so that just say the name Rohan, if we use it once, it's not going to come up again. And so that's just so that we get a unique set of 10 names. We sample between 1700 and 1990, so we pick integers out of that, and for our birth year, and we're picking 10 of those, and we are allowing the prime ministers to have the same birth year possibly. This is in our simulated dataset, of course. Our years lived, we expect, well, a prime minister is probably going to live somewhere between 50 and 100 years, and so again we need 10 of those, and again we allow them to live for the same amount of time because that's something that could happen. And then finally we expect that our death year should be birth years plus years lived, and so there's a few checks here that you could easily put in place if you wanted to. So you could have firstly that birth year is between two numbers. You could check that death year is equal to years lived plus birth year. So there's a whole bunch of checks that immediately simulating the data identifies could be useful. We also start to think about the appropriate classes because it's clear that our prime minister is probably going to be a character class, whereas birth year, years lived, and death year are probably going to be well placed as integers. Anyway, once we sample this, we end up with an example dataset, and so this looks pretty good. And so if I had a partner, I could give this dataset to them, and they could go off and start doing some graphs. The other thing that we might like to do at this point, while we're getting started, is to make a quick sketch of what the graph should look like, what we have in mind, and this just tries to make sure that what we have in mind is realistic, is doable given our skills, and we have some sense of how to approach it, and also is achievable given the data set that we expect to be able to get. I mean, you always run into problems in scraping, more often than not, you'll run into unexpected problems. But it's nonetheless useful to begin with an end in mind, and this is the graph that I had in mind. And so on the x-axis we have the year, and so this is going to be some value from 1800 through till today. We're going to have slightly different colors based on whether the prime minister is alive or passed away, and then on the y-axis is going to be each of the individual prime ministers. So that's what we have in mind. So let's go and execute this, and the first step is to go and gather some data. So now obviously this is a planned out lab, so it's a little bit artificial, but in general we are starting with a question, and the question that we're interested in is, well, how long is each Canadian Prime Minister living? And so in that world we might like to try and think about data sets that we might be able to get. So we're hoping that we have a data set that has some sort of structure to it, because when we're scraping when we're scraping websites, we're going to exploit that structure. And we're hoping that we have a data set that is trustworthy, because we would like for our story to be somewhat factual. Now in our case, the Wikipedia page of the list of Prime Ministers of Canada, I think probably fits both of those criteria. And so just to have a quick look at it, this is what it looks like. And so the aspect that we're going to focus on here is this table, because it's all nicely set up and all of the information that we need. Just returning now to our notes. So what we need, firstly, is some sort of equivalent to read CSV, but for websites. And in this case, we use the harvest package, and within that package, we used read HTML. And so that's, for those of you who are used to this read CSV business, it's just equivalent for that, except we are going to pass it a HTML page. And so in this case, we just go in, we grab, copy, paste the website address there, and we pass that as the sole function, sole input into read HTML. Now, once we've read the HTML, and in our case, I've called it raw data. Now that website is now living on our, well, the data that we read from the website is now sitting locally. It's on our computer. And so one thing that I like to do at this point is to save it. And so we need some sort of equivalent to save our HTML page. And in this case, the equivalent is write_HTML. And that's going to take two arguments. The first is the HTML that we need to save. In this case, we called it raw data, so we're going to give it raw data. And it needs a location. And so in my case, I tend to set up my folders with inputs, outputs, and scripts. And so in my case, it's going to go into an inputs folder within, and then within that, a wiki, and then it's going to be pms.html. That HTML bit is important because we need to tell it what type of data it is. Now, I tend to save this data for a number of reasons. Firstly, it's just polite because it means that we don't have to keep visiting their website every time we want to start again with our data analysis. We're going to make plenty of mistakes as we're going through. We're going to need to be restarting every time. And so if we save our own copy, then we can just go to that local copy and not have to hit their website. And so that's just being polite. It's also a nice way of enhancing the reproducibility because that way in 2 weeks I can come and I can see what you exactly the website that you were able to look at because you've got the website's data there. On the other hand, the website in all likelihood isn't our property. So in the case of Wikipedia, obviously it's a little bit different. People probably don't mind too much if you're sharing the website. But if we were scraping the data from, say, a private company, then we might like to be a little bit more careful about whether we are uploading our own copy to sources like to places like GitHub and things like that. It's just about being sensible and polite in terms of using somebody else's data. There's nothing wrong with what we're doing. It's just about being polite. So now that we have the HTML text, we need to go through it and we need to try and find the data that we are interested in. And the way that we're going to do this is we're going to parse the HTML. So parse, P-A-R-S-E, parse, sorry. Very Australian to say parse. And so websites are made of HTML, CSS, and so this is a markup language. And so what we're looking for are the tags that are going to distinguish the areas that we are interested in. And so these are the patterns. And so this is going to take a while for you to become comfortable with. And even simple examples take a lot of time. But what we need to be able to do is we need to look at the HTML code itself. And so one way we can do this is by going to the website. In this case, I'm in Firefox, but it works just as well in most of the other browsers. We right-click and we view the page source. And in that way, we can look at the actual source. And so we're going to look through this and we're going to try and find the information that we are after and look for commonalities. Another way to be able to see the page source is to open the page that we saved, but instead of opening it in a web browser, just right-click on it and open it in a text editor. And in that way, you'll be able to have a look at the actual source. And so we're looking for patterns that are surrounding the information that are of interest. And in our case, the information that is of interest are the names and birth date, death date, that sort of information, to do with the prime ministers. And it turns out that there is something going on with TR and TD, and these have to do with making tables in HTML, and so that's probably not too surprising. And we can focus on those nodes with the HTML nodes function. And so the input to that is firstly the raw data, and then HTML nodes goes through and looks for these particular nodes. And then once it's found those nodes, then we pass that and we look for other nodes. And so it's this combination of TR and TD that is going to give us what we are looking for in this case. Once we've zoomed in on it a little bit closer than we have, then we use HTML text, which is a function that removes most of the HTML tags, and it just gives us the text that we're interested in. Now I have passed 2 levels here to illustrate HTML nodes passing from one to another, but we can actually just put that into the one call to HTML nodes if we want. And finally, you'll notice that I have used HTML nodes. I've used the plural. And so that's going to give us every single node that matches the criteria. But if we just wanted one, then we could use the singular HTML node, and that would be completely fine. And so once we have passed this and had a look at and insisted on just looking at the HTML text, then we are getting much closer to what we are after. So we have a character vector, and most of the tools that we've been using in this course to date have been structured around data sets, around sort of rectangular data sets. And so we would like to convert our character vector to a table, and then we're going to just focus on the information that we want. And again, this is a matter of just inspecting the data and looking for commonalities that we can exploit. It turns out that in this case, the commonality that we can exploit is that every time there is a new Prime Minister, the line immediately above it is blank. And so what we're doing in this code is we are identifying lines that are completely blank, and then we are looking at the one immediately below it, and that turns out to be the line that has the Prime Minister. And so we are just filtering down to only those rows. The result is that we are getting pretty close. So if we look at where we are now, we have a column that has Sir John A. MacDonald, and then it's got a birth date, it's got a birth year, and then it's got the MP there from the riding that they were representing. So we're getting pretty close. But I know, of course, sometimes it's difficult to find which combination of nodes is going to get you exactly to the information that you want. And so there is an easier way, and that is with the selector gadget. I'd encourage you to go and have a look at the vignette for the selector gadget. I've included the link here. But this allows you to use a sort of pick and choose the elements that you want. And so the vignette shows you how to set this up on your computer, but returning to Firefox here, once you've got it set up, you just can click the selector gadget, and then select the rows that the information that you're wanting. And so at this point, it's saying, well, I'll get this is what you selected, but this is also going to be included. And so we can click on those again to say, well, we don't want that. And so now we're getting all of these yellow ones. And so that looks pretty good. That looks pretty much what we're after. We're getting this one little odd bit here with the Unionist Party, but it's only one issue. If we scroll through, it's only one issue, and so we'll just deal with that manually. And so now selector gadget gives us the code that we want, and so we just copy and paste that in, and that's going to make our life a lot easier. And so in our HTML nodes input, so this is an alternative to doing what we did before, we just paste in the code that the selector gadget told us is relevant. Now this does make your life a lot easier, but it doesn't always work. Sometimes it's a bit more complicated, and you do need to be aware that sometimes there are those sort of false positives, as it were, where the selector gadget is saying, okay, well, I'm going to give you this data. So in our case, it was this Unionist Party result that we are going to get, but we don't want, and so we're going to have to be careful to filter that out. But nonetheless, the selector gadget is a useful tool and something you should definitely consider using. Okay, so now we have the parsed data. We'd like to clean it. And so remembering our generated dataset, our simulated dataset, we are wanting a column of names, we're wanting a column of birth years, and a column of death years. At the moment, all of our data is pretty much just all in the one column, and so we're going to use separate to separate that column into multiple ones. And so separate takes as an input it takes firstly the data, and we're piping that, and then it takes as an input the column that you are wanting to separate. You tell it the names of the columns you'd like to separate that column into. You tell it to separate what to separate based on. In our case, we want to separate based on an opening bracket. And because an opening bracket is one of those special symbols in terms of regular expressions, we need to escape the opening bracket. And so that's why we've got those two slashes. Remove false is here, and that's just so that we include the original column. So we're focusing on raw text. So by default, separate removes raw text. And so remove equals false just means that we keep that column. Finally, once we've done that, then we would like to further separate the not name into whether it was a date and all the rest, because we're going to remove all of the rest. And once we're done that, it ends up looking a little bit like this. So you can see we're zooming in slowly on this name, we're zooming in slowly on the date, and so then we just need to do a little bit more cleaning, but we're pretty much there. And so this is looking pretty good. So the cleaning that we're going to do is just to separate birth and death into two different columns, because they are separated by what looks to be like a little hyphen, but it's actually some slightly different character pretending to be a hyphen. So we just need to copy paste that one in. And then we need to, so some of the prime ministers are still alive, and so in their case the setup is slightly different, and so that's what's going on in this line here. And then finally, we just need to do a little bit of cleaning around the names, removing some of the remaining HTML tags, and fixing up the class. So that's what's going on here. That's just removing some of the HTML tags, fixing up some of the classes, and then creating our age at death. Some of the prime ministers, they had a couple of goes at it, and so we just used distinct to ensure that we only get one entry for each prime minister. And so now the dataset's looking pretty good. So our first prime minister is Sir John A. Macdonald. He was born in 1815, he died in 1891, and he was 76. And so at this point, it might be worthwhile putting in a few tests just to check that our data are reasonable. If we were looking to sort of move this into production, then we'd certainly like a few tests, but for now, we'll just keep going and try and finish up the lab and make a graph out of it. So remembering our brief sketch of what we would like the graph to look like, if they're still alive at the moment, then we would like them to run through to 2020, but I think that we would like to color them differently just to denote the fact that they're still alive. And so we're going to start with our clean data set and then create that different setup for are they still alive or not. And then we are going to move to ggplot. Now there's a few new commands here, few new arguments here that you may not have seen before, xend and yend, and this is just because we are using geom segment. And so geom segment takes a starting point and an ending point, and so that is why we need the xend and yend for each of the x-axis and y-axis. In our case, we just want a flat line for each prime minister, and so our y and our yend are going to be the exact same value, but of course our x and our xend are going to be different values because we want a line that starts when they were born and ends when they died. We're going to color it by whether they're alive or not at the moment, and then finally we're just going to add some nice little labels and play with what it looks like a little bit. And so we arrive at the end and we have our nice graph. It's looking pretty good. We see Justin Trudeau, so he's here. The Prime Minister before him was Stephen Harper, so this is all looking fairly reasonable. Justin Trudeau, so how old is he? So he's looking gosh, he's looking like he's born in the early 70s or so, so he's quite young. Kim Campbell was slightly younger than we may have expected her to be based on the Prime Minister, the age of the Prime Ministers either side, as was Joseph Clark, perhaps. And then we go into the ones who have passed away, and so we see Justin Trudeau's dad passing away in 2000, and then earlier and earlier. These ones at the start, you see that there's a lot that was sort of born around the same time. You actually see this in Australia as well, where it turned out that there was, when the parliament began, there was just this cohort of people who were going to be prime minister, and it turned out they were all around the same age. And it's only after that cohort done being prime minister that we then start to age. We then start to age through, as we would expect. So what we've managed to do in this lab is to go to Wikipedia. We've downloaded some data, and we've done that in as respectful a way as we can. We have cleaned it up, parsed it, so we got out the information that we were hoping for, and then we identified the names and birth year and death year of each of the prime ministers. And then finally, we've made a fairly good-looking graph that illustrates what's going on in terms of the Canadian prime ministers by the year of birth. So we'll leave it there. If you have any feedback, please get in touch, because it would be great to know. Otherwise, I hope you have a good night.